Hey kids, today we're going to go over the 2018 AP CSA free response question number 1. This is another pretty simple AP CSA question. This is like the 2019 example we went over in the other video. This one's really looking for you to draw methods just like the other one. Remember, one of your questions is going to be about control structures and methods. And here's another example, kids. Much like the other advice I gave you with the other question, the same thing holds true here. Everything you need to write this code is on this page right here. So before you get too into anything, I would just take a second and just familiarize yourself with this page. So it says, this question involves reasoning about a simulation of a frog hopping in a straight line. The frog attempts to hop to a goal within a specified number of hops. The simulation is encapsulated in the following frog simulation class. You'll write 2 of the methods in this class. So we have our public class frog sim, and the distance in inches from the starting position, that's going to be the goal distance. Our maximum number of hops allowed to reach the goal, that's going to be our max hops. Frog simulation, well, this constructs a frog sim where the distance is the distance in inches from the starting position to the goal, and num hops is the number of maximum hops allowed. That means this is going to tell us how far we have to go and how many hops we have to get there. Hop distance returns an integer representing the distance in inches to be moved when the frog hops. The Boolean simulate returns true if the frog simulation has reached the goal, false if it doesn't. And double run sims, look, that's our first double we've had in a while, kids. This simulation runs and returns the proportions of simulations in which the frog successfully reached the goal. This is what we're going to have to use to write our code. So, kids, take a moment again, read it over and understand, because these are the parts we're going to need to use to write our code. The next part's usually an example and the question. So we have write the simulate method, which simulates the frog attempts to hop in a straight line to a goal from the frog's starting position of 0 within a maximum number of hops. The method returns true if the frog successfully reaches the goal within a maximum number of hops. Otherwise, we need a false. The frog sim class provides a method called hop distance that returns an integer representing the distance, positive or negative, to be moved when the frog hops. A positive distance represents a move towards the goal. A negative distance represents a move away from the goal. The return distance may vary from call to call. Each time the frog hops, its position is adjusted by the value returned by a call to the hop distance method. We have 3 conditions that the program is going to run until one of these are met. And the frog has reached or passed the goal. The frog has reached a negative position and gone the wrong way, or the frog has taken the maximum number of hops to reach the goal. Over here, we have our example and frog sim, new frog simulation 24.5. 24 is the distance to the goal. 5 is the maximum number of hops to get there. We come down here, 5, 7, negative 2, 8, 6. If you add all those up, it's 24. 24 is our distance, so it is true. 6, 7, 6, 6. If you add all those up, that's 25. Well, that is also true. Here we went 6. We went back to the starting position. Then we jumped 31. Oh, that's one heck of a jump, kids. That's above 24, so that's true. This time we went 4 to negative 8. The position is negative, so that becomes false. And this time we jumped 5 times. We only got 18, so that one was false. This is just an example of this right here, kids. We have our class information to look at here. Again, this is a good little cheat sheet of what you got to use. Here is our question. complete the method simulate below, you must use hop distance appropriately to receive full credit. So we're going to simulate a frog attempting to reach a goal as described in part A. Return true if it does, or false if it doesn't reach the goal. Kids, let's talk this through over in Replit as we code up this answer. Here we have our method that we have to finish. And remember really what we're trying to do here, kids. We're trying to write a program that will satisfy one of those three things. Did it reach the goal? Did it take too many hops? And is it negative? How are we going to write that out? Well, if we come down here, the first thing we need to do is just keep track of our position, right? So we'll just make a new integer, position, and we're going to set that equal to 0. Now, once we get that, we need to start keeping track of that position. How are we going to keep track of it? Well, we're going to make a for loop. So we're going to do for, and we need an integer for hops because we need to know how many hops it's taking. So we're going to set it initially to 0. If our hops are less than our max hops, so that's the maximum number of hops, we're just going to add hops plus plus. Now within that, kids, we're going to have to keep track of our hops, right? Or our position. So we're going to reset our position. It's just going to be position is going to be equal to position plus whatever that hop distance was. So we're just going to use that hop distance to update where we're at for our little frog. And once we know that hop distance, well, if the position is greater than or equal to the goal distance, remember that piece of information we were given, well, we're going to return true. Else if, and then else if our position is less than 0, because that's the second part of that, kids. Remember, if it's above the goal, we want 1. If it is less than the starting position, we want to return false. Now, as it works its way around, kids, remember, it can get the maximum number of hops, right? If it reaches that maximum number of hops, we just want it to return false. And I think I have one too many curly cues there. And this one should open up the large one here. This one's opening up this one. Oh, we need one more, kids. And that should be the correct code for 1. So again, what's it doing here? We're just setting our initial position of 0, where the frog starts. It can hop along as long as it doesn't reach the maximum number of hops. Remember in our example, that was 5. We're going to get our position, and we're going to add whatever the distance is. If the distance is greater than a goal distance, we're going to return a true. Else if the position is less than 0, going backwards, we're going to return false. And if it reaches the maximum number of hops, well, we're going to return false again. And kids, well, that's the answer for A. Let's go ahead and look at B real quick. B says, write the run simulation method, which performs a given number of simulations and returns the proportion of simulations in which the frog's success reached or passed a goal. For example, if the parameter passed to run simulation is 400 and 100 of the 400 simulation method calls return true, then run sim ran 0.25% of the times. And we're going to complete run simulation below. And we're going to have to pass this integer num off here eventually. What it looks like we're doing here, kids, is we're just writing a program that is going to keep track of how many times we're successful. And to get a percentage, we're going to take how many successful runs there were and divide it by the overall simulations. 100 divided by 400 is a 0.25. That doesn't sound too bad at all, kids. Let's jump over to Replit and code this up. Here we are over in Replit. And what do we have to do again? We are just keeping a track of how many successes there's going to be. Remember though, kids, it's going to be a percentage, 0.25. So that means everything is going to be a double that we need. Let's start with our variable to keep track of our successes. And again, I'm just going to make this a double, and I'm going to call this success. And we're just going to set this to 0. Now we just got to keep track of how many times it's true, right, kids? So that's just a for loop. And we're just going to make another variable run. This is how many times the simulation is going to run. We're going to set this equal to 0. As long as the run is less than the number of simulations, we're just going to progress through our simulation. That's all that says there. So run sets to 0. We're going to keep going through the number of simulations till we hit the num, and then we're going to return. And as long as we're underneath that, we're just going to progress up. Well, kids, we have this neat little Boolean statement up there, simulate, that we can use. So if simulate is true, well, we're just going to add 1 to that success counter. So we're going to go success plus plus. And once this has met its needs, so as this runs through, kids, we're going to need to return the overall number of simulations, right? So we're going to return the number of successes divided by num. And that will give me a percentage. So if it was correct 100 times, 100 divided by 400, like the example, that would give me 0.25. And again, why is that going to return 0.25? Because we used the double up here. And that's it, kids. That is the answer to B. Hopefully you found this video helpful. As always, if you have any questions, let me know. Otherwise, kids, I'll see you on the next video. See you later, kids. Bye. Bye. See you later.